Hello students, welcome to Sources classes, and this is ISI M.MATH 2018 question paper full solution. Then we are studying it in this video from question number 4, which is a ring theory based problem. So is it ideal that I equal to x plus y x minus y is a polynomial ring of C of xy is a prime ideal? So let's do it. X equal to what we can say, x plus y by 2 plus x minus y by 2, and y equal to, we can take x plus y minus half of x minus y. If we take that, so it implies that I equal to x of y, and the general element of I is in the form of xp xy plus yq xy. That is I of p c. So p of 0 comma 0 equal to 0. So now if belongs to I, then p of 0 0 q of 0 0 equal to 0, which is possible only when p of 0 comma 0 equal to 0 or q of 0 comma 0 equal to 0. So I is a prime ideal. So first part done. Next, part B. In part B, they have given, is the ideal in the polynomial ring a prime ideal? Okay, so let's assume that I is a prime ideal in z of x comma y. So if we consider the polynomial x of y, then 2x equal to, obviously this time we will not be dividing, so we will write it in this way, x minus y. So that is also belongs to I. So either 2 belongs to I or x belongs to I. So the general element I is in the form, we can write x plus y q of xy plus x minus y r of xy, and second part is q of x comma y, third is r of xy belongs to z of x comma y. So this is the stuff here. So in particular, an element of I vanishes when I vanishes when x equal to y equal to 0. So that is 2. So 2 does not belong to I, so it follows from x belongs to I, and obviously we can do it as x plus y q of xy x minus y r of xy. So this is finally x q of x comma y and r of xy. Okay, so obviously then from this above, qxy is r of xy, and x equal to 2qxy into x comma 2qxy, and that is equal to 1, which implies that, which is impossible actually. So which implies impossibility in zxy. So I is not a prime ideal. So answer is no. Next question 5. This one is on linear algebra. N greater than equal to 2, A be an into n matrix with real entries. Let adjoint of A denote the adjoint of A, and so I is the nth entry, so that the rank of the adjoint is 0, 1 or n. So if determinant of A not equal to 0, so then the inverse of A is given by adjoint of A, and the rank is n. So assume that the rank of A is less than equal to n minus 2. So then each n minus 1 cross n minus 1 minor is 0, and all elements in adjoint of A is equal to 0. So in this case the rank of adjoint is also 0. So first part done. So now actually we need to get into this thing. So assume that the rank of A is now n minus 2. Sorry, n minus 1. So there exists a non-zero structure again, n minus 1 into n minus 1 minor. So adjoint of A, so rank of adjoint of A, this is greater than or equal to 1. So denoting that Aij is the I comma jth cofactor of A. So then adjoint of Aij is A to the power ji. So if we consider the product here, so A dot adjoint of A, then it is I comma jth entry is will be summation of Aik adjoint of A kj, where k equal to 1 to n, remember this part, and obviously this will be equal to now summation of Aik will remain as Aik, and this part will be only A to the power jk. So this is part 1. So indeed if I equal to j, then the sum in 1 is the determinant of A. So this will become 1 will give determinant of A, and if I not equal to j, then the sum of 1 is the determinant of the matrix. So the sum is determinant of the matrix A after the jth row is replaced with ith row. So such determinant is 0. So the determinant is 0 as the matrix has two identical rows. So this we have a two identical rows. So we see that A into A dot adjoint of A is 0. That is, each column of adjoint of A is each column is the kernel of A. But obviously here we can see that rank of A is n minus 1. Hence the dimension of kernel is of A is 1, and the dimension of the column range is less than or equal to 1. So obviously this proves that the rank of adjoint is 1. So this is the only common, so the rank of the adjoint is 1. That's the answer.